Welcome to the November 2019 issue of the AJP-Heart and Circulatory Physiology video table of contents, or from the editor's desk. This month we have two reviews and one very important guidelines in cardiovascular physiology paper, along with some great original research papers. The guidelines paper on the measurement of cardiac cell death has just been transformed into an outstanding podcast. So please be on the alert and listen in. Very informative by leaders in the field. Now let's see what's inside. Review by Tsutomi et al. Provides evidence supporting the hypothesis that cardiomyocytes are an initiating site of inflammatory gene expression in response to non-ischemic stress. The authors discuss the role of multifunctional calcium calmodulin regulated kinase, or CAM kinase 2 delta, as a transducer of stress signals to nuclear factor kappa B, or NF-kappa B activation, expression of pro-inflammatory cytokines and chemokines, and priming and activation of the NOD-like pyrin domain containing protein 3, the NLRP3 inflammasome, in cardiomyocytes. They summarize recent evidence that subsequent macrophage recruitment, fibrosis, and contractile dysfunction induced by angiotensin infusion or transverse aortic occlusion are ameliorated by the blockade of CAM kinase 2 of MCP1, CC chemokine receptor 2 signaling, or the NLRP3 inflammasome activation. Our Guidelines in Cardiovascular Physiology series provides crucial information on evaluation of cell death. Recent studies revealed multiple forms of cell death, and several of them have been demonstrated to underlie adverse cardiac remodeling and heart failure. It is important and timely to set guidelines for the best practices of evaluating myocardial cell death. The authors discuss the 6 major forms of regulated cell death, namely apoptosis, necroptosis, mitochondrial-mediated necrosis, pyroptosis, ferroptosis, and autophagic cell death. They describe the best methods to identify, measure, and evaluate these modes of myocardial cell death. In addition, they discuss the limitations of currently practiced myocardial cell death mechanisms. Ahmad et al. Review the gut microbiome in cardiovascular disease. The human body is populated by a diverse community of microbes dominated by bacteria, but also including viruses and fungi. The largest and most complex of these communities is located in the gastrointestinal system, and with their associated genome are known as the gut microbiome. This review focuses on the role of the gut microbiome and associated functional components in the development of and progression of atherosclerosis. Potential treatments to alter the gut microbiome to prevent or treat atherosclerosis and cardiovascular disease are also discussed. Stephenson and co-workers review the role of pregnancy-associated plasma protein A, or PAP-A, a metalloproteinase with a well-established role in releasing bioactive insulin-like growth factor, IGF-1, from IGF-binding protein 2, 4, and 5 by proteolytic processing. The IGF system has repeatedly been suggested to be involved in the pathology of atherosclerosis, and both PAP-A and IGF-1 are proposed biomarkers and therapeutic targets for this disease. Romery et al. Evaluated additional distinguishing factors other than diameter between growing and stable murine aortic aneurysms toward the aim of eventually improving clinical rupture risk assessment. By utilizing a relatively new mouse model that combines surgical application of topical elastase to cause initial aortic expansion and a lysyl oxidase inhibitor, BAPN, they were able to create large aortic aneurysms that expand over 28 days. They further sought to develop and demonstrate applications of advanced imaging approaches, including 4-dimensional ultrasound, to evaluate alternative geometric and biomechanical parameters between growing aortic aneurysms, stable aortic aneurysms, and non-aneurysmal control mice. The results from this work provide clear growth patterns associated with BAPN elastase murine aneurysms and demonstrate the capabilities of high-frequency ultrasound. These data could help lay the groundwork for important insight into clinical prediction of abdominal aortic aneurysm expansion. Merzo and colleagues investigated mitochondrial function and ROS production in cerebral blood vessels of 21-week-old Zucker diabetic fatty obese rats and their lean controls. They found that the same segments of mitochondrial respiration, basal respiration and proton leak, were diminished in diabetic groups as they were in younger diabetic animals. Superoxide levels were significantly higher in large cerebral vessels of diabetic animals compared with the control group. Prolonged dietary diabetes leads to stabilization rather than deterioration of metabolic status in the cerebral circulation, despite continued overproduction of ROS. Thank you for watching the November edition of From the Editor's Desk. Please don't forget to visit our website and provide us feedback on journal articles and anything else you would like to see added or deleted from our article types. We look forward to seeing you next month, and please don't forget, send us your best work now.